Now, how do we know the difference between a sine and cosine graph? What you need to realize is that all sine graphs, the red one here, at 0, sine is always 0. For cosine, it's your amplitude. If your amplitude's 1, it starts at 1. If your amplitude's 5, it starts at 5. It depends on your amplitude, your A value. If it's negative, it gets flipped upside down. But the key is we know sines always start at 0 with 0 as an output. That's huge. So when we look at this graph, can you tell right away if it's sine or cosine? Now we said this is a sine graph already. But before we write the equation of a sine graph, let's first say the amplitude and period. It doesn't ask for it, but it helps. Hopefully you can tell your amplitude from here to there is a 3. So my amplitude is 3. And your period is always this cycle. You want one cycle. And what is the interval of that first cycle? Pi. So you should know that your period is pi. Now, I want to write the equation. I know it's a sine graph because it started at 0. Now, hopefully you caught on their amplitude is always that front number. But the period is pi. But how does that relate here? Well, what I like to say a lot of times is that, do you see within a 2 pi period, how many cycles of this graph do you have in a 2 pi period?
2.
Do you see we have 2 cycles? So what I like to say, instead of saying pi, I like to think of that as, well, that means I have 2x. I have 2 cycles in a 2 pi period. So each period, technically, is pi. Because there's 2 cycles each of a pi length interval. And what is the number in front? 3. Now, if this was upside down, I would have a negative 3. All right, this problem right here, we're going to sketch one cycle of a cosine curve. Got cosine there. Amplitude of 2 and a period of 4 pi, and then there's the equation. So if I know my period's 4 pi, what I like to do is I first like to just put 4 pi right there, because that's how far it's going. So half of it would be 2 pi. So the first thing I like to do when I know my period's 4 pi, I like to put 4 pi down. Then I know my amplitude's 2, so can you put a 2 there and a negative 2 there? So if I know my amplitude's 2, I got boom, 2, 2. And I know my period's 4 pi, so I know it going to there. And then I know it's cosine. Doesn't cosine this blue graph right there? So now let's simply draw the blue graph on this set of axes. So to do that, you'd start there, because that's cosines always start at the top. It's going to go down to here in the middle. Doesn't it go down in the middle? And back up. And then if you look at closely, do you see how cosine always hits right here and right here? So it hits right there, hits right there. So can I put a dot right there and a dot right there? Not very good dots, huh? Pretty ugly dots. Now, can you create that curve? Not a V. It looks like a V. Don't put a V. Can you hopefully see the curve? Mine's going to be so ugly here. Well, actually better than I thought it would be. Well, I'm proud of myself. And I'm going to mess it up. Okay. Not bad. All right, can you see that shape right here? Can you see we have a height of 2 and a lowest point of negative 2? Can you see a period of 4 pi? I followed what this said. Now, quick thing. Did it say anything if it's upside down or right side up? Could I technically have written this upside down and it'd be okay? The problem did not mention that this is positive up. You could have technically drawn an upside down one and technically been okay because it didn't say anything about which direction. But in general, if we don't give specifics, assume it's positive. Just as the more common. If we're not given specifics, assume it's positive. Should have been more specific. Anyways, with this red graph, I now want to write an equation. Are we okay? The amplitude is always real easy in front. Most of you are pretty good at that. The hard part will be this. If the whole thing is 4 pi, how much do we get in 2 pi? Do you see we got half of it? See how half the graph is done in 2 pi? So I write my answer as half of it, x over 2. That would be my equation for the cosine statement we got given, my graph and my equation. y equals 3 sine 2 theta. From 0 to 2 pi, how many cycles and what are the amplitude and period? So let's first start with amplitude and period. That number is always your amplitude. So your amplitude is 3. Now your period is a little bit harder. If I have 2 cycles in a 2 pi period, here's the formula you're technically using. Aren't you starting with 2 pi? And if I have 2 cycles, wouldn't that mean I divide 2 pi into 2 sections? Yeah. That's what you're doing. You're taking 2 pi and dividing by this number. So I take 2 pi divided by 2, so my period is pi.
Do you do that with every single one? Like you put 2
So now can I graph this? Hopefully so. It's a sine graph. So hopefully you realize sine graphs look like this. They start at 0 and go up and down. But my first cycle is going to fit in here. And then I'm going to have another cycle in there. So I have 2 cycles. So watch what happens. I'm going to start at 0. I'm going to hit right here in the middle. I'm going to start at 0, go up, come back down. Right there, go up, come back down. There is 2 cycles of my sine graph in a 2 pi period. This is amplitude of 2, 3. Almost missed that. That's a 3 in front, and this is a negative 3. And there's my graph. Now the one thing I forgot is, how many cycles do I have in that 2 pi period? 2 cycles. It actually asks for that, so it's 2 cycles. That's what that means right there. If that was a 5, I'd have 5 cycles. If that was a 1/2, I'd have half of a cycle. First of all, change that to a 2 just because it works out better. You should notice your amplitude is 2. You should notice your period. Well, your period is 2 pi divided by 1/2. This is kind of 2 pi divided by 1/2. So 1/2 is ugly. It's like a pi half. And when I go 2 pi divided by 1/2, do you understand that's 2 pi times 2 over 1? Which is 4 pi. Kind of had to squeeze that in. 2 pi divided by 1/2, that's a half there, becomes 4 pi. And it's a cosine graph. Now, if I go 4 pi, do you guys understand? When I have a 1/2 here, aren't I going to only do 1/2 of it in a 2 pi period? I'm only going to get half the graph. And it's upside down. So I have half a cosine graph upside down. Do you see why a 3 would have been ugly? A third of the graph, ooh, that'd be kind of hard to graph. So I'm going to get half the graph of cosine upside down with the amplitude of 2. So watch what it'll look like. It's upside down with an amplitude of 2. So let's see. Here it's starting at 2 upside down. All right, we're doing a half a cosine graph. So half a cosine graph kind of looks like that. The other half would be on the other side, which you can't see, but there it is. It's half of this graph upside down. Can you see that? Take that graph, flipped it over, and half of it. Now, this right here was a little messy. Again, 2 pi divided by 1/2, which is 2 times 2 pi, which is 4 pi. Kind of messy. Can you see if this is 2 pi, you extend it again there, so you get your 4 pi as your period. And let's write here, let's put 2 there and negative 2 there. So we have labeled our actual amplitude is labeled. Got to make sure that's labeled. So now we want our range. Now our range is just from, well, our lowest point is negative 2 to our highest point of 2. So it'd be from negative 2 to 2. That would be your range for this particular cosine graph. And again, I changed that to a 2 there because a third would have been a little uglier than I'd want it to be.